Today we are working with Activity 5 in the packet for electricity. The first thing you are supposed to do is look at the setup. You can see I have two bulbs and they're lit. I have a closed circuit and I do have a compass in here. We're going to use this to help us deflect, to see what deflection happens when we bring a wire next to it. So the question in the middle says, what does a compass tell you about what is happening in the wires? So we're going to use the compass to help us determine if there is something happening in the wires. Now, to begin with, you're supposed to make a few predictions here. So the first one says, predict the relative strengths of the vertical activity in each, or the electrical activity in each wire. So I want to know, is the activity in wire A, so I have these marked, here's A, this is wire A, B, how does that compare? Is it the same? Is one greater, have more activity, one have less activity than the other? And then I have wire C over here for my third one. So you can see they're labeled on the diagram as they are labeled on my setup. And then it says, predict the direction and the amount of deflection for each wire for the compass. So my question is, if it deflects this way, the compass, that would be clockwise. If it deflects the opposite direction, if it deflects this way, it would be counterclockwise. And we can just use that CW and CCW. Okay? So we're going to use those as our directions. And then the third one says, what would be the effect if reversing the battery pack on the compass deflection? So here we got the battery pack up here. So to begin with, this wire right here is connected to the positive terminal. If I flip this around and I made this be my negative terminal and this be my positive terminal, so I can just flip the whole battery pack, how would that change the compass deflection? So you are first supposed to make those predictions. So we're going to pause this and take a minute and make those predictions. So as we proceed ahead, now you are supposed to record over here what happens to the compass as I put the wire over top of it. So to begin with, you're not going to see my whole circuit here, but you can see I have the bulb lighting there. So we're going to look at what happens to the compass when I put the wires. So this is wire A. So I'm going to take wire A and I'm going to lay it parallel to the needle. Notice what happens. Oh, that needle moved. When the wire was brought up, the needle moved this direction, so that would be clockwise. So if we look at that again, you can see it moved, and it looks like it moved about 10 degrees. Okay, I'm going to rotate this around, and I'm going to bring my next wire in. This is wire B. And I'm going to bring this one up. I'm going to keep it orientated the same. Oh, it looks like it did the same thing. When the wire comes up, it moves clockwise. The red part of the needle is moving that direction, and it moved 10 degrees. Now, wire C. So I'm rotating the wires around. So here's wire C, the third one. So I need to keep everything orientated the same. So wire C, when I do this, oh, looks like it did this exact same thing. It moved clockwise 10 degrees. So I'm going to put my stuff back in order like I had it before. Erase this. Now, here's my battery pack. I'm going to switch around these two wires. So I'm going to do this wire that was on this end is going to go to this side, and this was on the other end is going to go to the opposite side. So now I want to take these wires and set them over. So this is wire A again. Oh, didn't that deflect and go the opposite direction? You could see it moving. It went this way. So wasn't that counterclockwise? And it was about 10 degrees again. Now, here's my wire B. I need to keep it orientated exactly the same. It did the exact same thing, counterclockwise 10 degrees. And I'm guessing you can figure this one out. When I bring C over there, this is wire C. It's going to be the same thing, counterclockwise 10 degrees. So we need to come up with a conclusion for our activity. So we had our circuit here, and we had our 3 wires, A, B, and C, and we did our compass deflection to see how the compass was deflecting. So our conclusion should be something like this. The amount of compass deflection was identical in all wires. So when we're saying it was identical in all wires, we're going to say for one setup. So when you had it hooked up to the battery in one direction, all the wires were the same. The deflection direction was also the same. So when we had one setup, they all deflected clockwise 10 degrees, or they all deflected counterclockwise 10 degrees. So reversing the battery caused the deflection to change direction but the amount of deflection remained the same. Or was constant, we could say. So in other words, that's telling us that whatever's happening in the wires, the amount of deflection was the same, so the same of something must be happening in all of those wires. So whatever is happening in wire A is the same thing that's happening in wire B, and it's the same thing that's happening in wire C. When we just reverse the direction of the battery, we change the direction of something. So that's our conclusion. Now, we're going to come up with some new terms here. So our terms are going to be this. Charge is one of them. What we are detecting is the charge that is flowing in these wires. That's what the compass detects. Now, you probably didn't know this, but any wire that has a current going through it, and this does because the battery's pushing it, it has a magnetic field around it. And then if it has a magnetic field, it causes a compass to deflect. Okay? So charge is the stuff that moves through the wire. Okay, so the charge, and so since every wire deflected the compass the same amount of charge must be moving in all of those wires. That's what that's telling us. So that the compass is really being used as an instrument to detect the charge. Okay, now there's something called conventional charge flow. So it's called conventional. The reason it's called conventional is when scientists were first studying electricity, they didn't know which direction it truly flowed. So they said, since they didn't know, and these particles were so small, they weren't aware of them, they said, we're all going to agree upon at this convention that charge flows in this manner. So the manner that they said was that the charge flows from the negative, and so the negative terminal is the one that has the knob, away from that to the positive terminal, which is the flat end of the battery. Okay, so the charge flows in a closed loop, so we know we have to have a closed loop. The positive terminal to the negative terminal. On a battery. So in my circuit, when I have this set up, and when we're looking at it, these are my wires. It's over here. When I set this up like this, if we look at my battery pack here, this wire is connected to this positive terminal. It's where it's connected. So we would say charge is flowing away from the positive. So it's flowing this way. And it's going to go through that wire, and it's going to go around, all the way around, and then it comes back to the negative, because this is the negative terminal. It's flat on this end. Okay? So that would be the direction of charge flow. And this is called conventional charge flow because all these scientists agreed upon this at a convention. So that gets us through activity 5. So we're using the compass to detect that something is taking place in the wire. And so we know if we have a circuit set up and we have the same kind of bulbs in the wire, we have the same charge flow in each wire.